Welcome to the IT free training video on DNS Time to Live, Aging, and Scavenging. Hopefully your DNS server will always return the correct information. However, if it does not, understanding how these settings work can help the administrator improve the accuracy of DNS records. The first setting that I will look at is Time to Live. Time to Live, otherwise known as TTL, is the time a DNS record is allowed to be stored in cache before it is automatically removed and a new query must be sent to a DNS server to retrieve the record again. To consider what this means, consider this example. A client wants to obtain the IP address for a DNS name. In order to do this, it sends a DNS query to a DNS server, in this case the ISP's DNS server. The ISP will then contact an authority DNS server in order to obtain the DNS record the client is asking for. Once the DNS record is obtained, it will be stored in the cache for the ISP's DNS. It will then be passed on to the client, and the client will store this record in its DNS cache. The problem occurs if the DNS record were to change, as the DNS record stored in cache would now be incorrect. The client and the DNS server now both have DNS records that are incorrect and will keep using the wrong information. This is where the Time to Live setting comes into play. The Time to Live setting allows the administrator to determine how long a DNS record can be used before the DNS server and client will be forced to requery the DNS record rather than using the cached version. By allowing the administrator the ability to configure this setting, this means the Time to Live can be configured according to the administrator's requirements. For example, a very static host that rarely changes may be configured with a very high Time to Live. The higher the Time to Live, the less queries the authority DNS server will receive. However, a high Time to Live setting does come at a price. If, for any reason, the DNS record were to change, a high setting would mean the old DNS record would be used for a long period of time. For mission-critical systems like email, administrators will often choose a lower Time to Live setting. With a lower setting, this means that if the email server went down and the IP address had to change for whatever reason, the time taken for the clients to start using the new DNS record would be reduced. In this case, it is better for the authority DNS server to receive more DNS queries for the email server than have it be uncontactable for an extended period of time because clients are using an old IP address. You can see why setting the Time to Live value is an important balance between responding to change and network traffic. The next point that I want to look at is DNS record aging. This applies to dynamic DNS records, that is, DNS records that have been registered by the client on the DNS server. It can also be configured on static DNS records, but is not by default. What essentially happens is that when a DNS record is created in DNS, a timestamp is added to the DNS record. This timestamp records the date and time the DNS record was created. As we will see later on in this video, this timestamp is used with scavenging to remove DNS records from DNS. The timestamp on a DNS record can be updated. For example, when a computer first starts up, it may attempt to update its DNS records on the DNS server using dynamic update. When this occurs, the timestamp on the DNS server may get updated. Yes, you heard right. It may get updated. Let's look at the reasons why this may or may not happen. Imagine that you have a typical network with hundreds of computers and devices on it. Each day, each of these computers starts up and attempts to update its host record using dynamic DNS on its local DNS server. This results in hundreds of updates received each day by the DNS server. This may not seem like a lot, but when you consider that each of these changes needs to be replicated to the other DNS servers on the network, you can start to see that in a large organization, this can amount to a lot of network traffic. In most cases, the client will have the same IP address and host name, so the only item that will be changing is the timestamp, and thus is a lot of replication traffic for the sake of keeping the timestamp up to date. You can imagine that on large company networks spanning the globe, updating the timestamp constantly is overkill and does not give any operational advantage. It only uses up bandwidth. So how does DNS Server reduce the amount of replication involved when keeping the timestamps up to date? DNS Server uses two settings called No Refresh Interval and Refresh Interval. These settings are often difficult for students to understand without understanding what they are trying to achieve. Just remember that two settings together are attempting to reduce DNS replication traffic and also ensure that a DNS record is not removed too quickly in case it is still needed. First of all, I will look at the No Refresh Interval. By default, this is configured for 7 days. In this time, the timestamp alone cannot be updated. This helps reduce the amount of replication traffic, but there are other changes that can happen to a DNS record. These changes are allowed to be made during this period. It is only if the timestamp is attempted to be changed by itself in this period that it is not allowed. For example, changes like the IP address changing or for a service record or port changes are allowed. The next setting is the refresh interval. This by default is configured to 7 days. In this time, any data in the DNS records can be updated, including the timestamp. The DNS records will not be removed in this time. This effectively gives the device that registered the DNS record 7 days to update the DNS server and thus let the DNS server know that the DNS record is still required. This essentially means, by default, it takes 14 days before a DNS record that is registered in DNS can be removed. You can see that using a system like this gives a balance between replication traffic, but also gives the device time to re-register the DNS record before it is removed. This brings us to the next topic, removing the DNS records. Scavenging is the process of removing outdated DNS records. Scavenging looks at the timestamp of the DNS record in order to determine if the DNS record should be removed. This will occur after the No Refresh Interval and Refresh Interval, which is 14 days by default. The important thing to remember with scavenging is that it is not configured by default. In order to configure scavenging, a number of settings need to be configured, which I will look at in a moment. If these settings are not configured correctly, scavenging will not occur. Also, for this reason, scavenging can appear to happen quite randomly. It is not uncommon for an administrator to be looking at DNS and seeing DNS records that they believe should be scavenged and they are not automatically removed, but later on suddenly disappear. The next point to remember is that if your clients are not dynamically updating their DNS records, this includes resources records used by Active Directory, these will be scavenged. Having all the resources records for your Active Directory domain controllers suddenly being removed can have an effect of preventing any user on the domain from being able to log in. So if you enable scavenging, the 2 points to remember are: be patient, the records will be removed eventually, and ensure there is nothing preventing your clients, especially domain controllers, from registering DNS records. I will now change to my Windows 8 computer to look at how to configure the DNS scavenging option using remote management tools. First of all, I need to open the control panel by opening Charms, select Settings, and then selecting Control Panel. Once the control panel is open, I will type in Admin in the search dialog in order to locate Administrative Tools. Once Administrative Tools is open, it is a simple matter to find DNS and open it. The DNS Admin tool will ask which DNS server you want to connect to. In this case, I want to connect to NYDC1. Once the Admin tool has opened, I will right-click on NYDC1 and go down to the option Set Aging/Scavenging for all zones. I will not select this option as yet because I want to demonstrate that this setting is also found in the zones. Before I look at configuring the scavenging setting for a zone, I will first expand down through DNS until I get down to the single DNS record for WS1. If I right-click on the DNS record and select Properties, you can see in here the properties for the DNS record, but there are some properties that are missing. To access these properties, I will close out of here, go to Menu View, and select the option Advanced. Once this is done, when I open the properties for the DNS record again, notice at the bottom is the time to live value. For this DNS record, the time to live is set to 20 minutes. This means that a DNS server will only be able to keep this DNS record in its cache for 20 minutes before it is forced to contact an authoritative DNS server to obtain the DNS record again. Above this, notice there's a tick box. Delete this record when it becomes stale. If this tick box is ticked, when the DNS server is running its scavenging process, this DNS record will be removed if the record is old enough, by default 14 days. The point to remember here is that if the tick box is not ticked, this record will not be able to be removed by the scavenging process even if I have configured other options for scavenging. By default, dynamically created DNS records will have this ticked and manually created DNS records will not. Below this, you can set the record timestamp. This is what the scavenging process will look at to determine if the DNS record should be removed. Assuming that all the DNS records that you wanted scavenged have the delete this record when it becomes stale option ticked, the next step is to configure the option in the zone file. To do this, I will exit out of this record and right-click the itfreetraining.local zone and select Properties. Once the properties are open, the next step is to press the button Aging. This will show the settings that are used with scavenging for this zone. To enable scavenging, all you need to do is tick the option Scavenge Stale Resource Records. In order to determine the time period the DNS record is allowed to exist before it is removed, the next two options are used. The first option, No Refresh Interval, will not allow the update of only the timestamp to be updated during this period, in this case 7 days. Any other changes in the DNS record can be updated. This setting is here to help reduce replication. Without this setting, every time a computer started up and it updated its DNS record, this change would need to be replicated. The next setting is the refresh interval. This setting determines how long after the no refresh interval the timestamp on the DNS record can be updated. So effectively, by using these settings, updates of only the timestamp can only be performed between 7 and 14 days. If the DNS records are not updated in any way in the 14-day period, the next time the scavenging process is run, the DNS record will be removed, assuming that the DNS record has the option Delete this record when it becomes stale ticked. In this case, I will untick Scavenge Stale Resource Records, and thus not enable scavenging to prove a point. I will now exit out of here, right-click on the NYDC1 once again, and this time select the option Set Aging/Scavenging for all zones. You would think by the wording this would configure scavenging for all zones, but this is not the case. As we will see in a moment, this only sets the default for Active Directory integrated zones. Notice that these are the same options that I had for the zone. If I tick Scavenge Stale Resource Records and press OK, I will be presented with a dialog message. Notice that the dialog states that Scavenge Stale Resource Records enabled. This would tend to suggest that all zones are changed. However, notice above this that this setting only changes the default setting for new Active Directory integrated zones. This does not affect existing zones, and if you decide to create a non-Active Directory primary zone later on, this setting will also not apply to those zones. If you want these settings to apply to existing Active Directory integrated zones, you can tick the tick box at the bottom. Apply these settings to the existing Active Directory integrated zones. In this case, I will not change the existing zones. However, I will go back to scavenging properties for the itfreetraining.local zone and tick the option Scavenge Stale Resource Records. Once ticked and the option applied, the DNS server will start removing outdated records the next time a scavenging process is run. You can wait for this to occur, or if you want to manually start the process, right-click the DNS server and select the option Scavenge Stale Resource Records. The point to remember is if you select this option, this only starts the process up that checks for DNS records that need to be removed. If the zone is not configured for scavenging, or the DNS record is not ticked to be deleted when the DNS record becomes stale, then no DNS records will be removed. There has been a lot covered in this video, so I will now go through a quick summary of the major points. The first point is that during the no refresh interval, the timestamp for the record cannot be updated or refreshed by itself. If other information in the DNS record was changed, for example, if the IP address of the client were to change, the DNS record can be updated. The refresh interval timestamp is when the timestamp can be updated and does not require anything else to be changed. It should be remembered that DNS records are only scavenged if the timestamp on the DNS record has not changed and is outside the no refresh interval plus refresh interval. This by default is 14 days. Also, the DNS record has the option ticked to delete if the record is stale, and lastly, if the zone is enabled for scavenging. If you find the DNS records on your system have not been removed, check all these options and be patient. Well, I hope you've enjoyed this free video from IT Free Training and found it informative. All our videos are free for this course and others. Thanks for watching, and see you next time.